Now we are going to learn the reverse bias characteristics of the Zener diode. Look at here, the Zener diode, it is connected in the reverse bias connection. The P end of the Zener diode, it is connected with the negative end of the power supply. N end of the Zener diode is connected with positive end of the power supply. And here, since it is connected in the reverse bias, the current which is passing through the circuit should be called as reverse current. The voltage which is given across the Zener diode must be called as reverse voltage. Now I am going to vary the value of reverse voltage, the corresponding reverse current to be observed. Are you clear? How to vary the reverse voltage? Here, this is the variable voltage supply. By dialing this knob, is it clear? The reverse voltage can be slowly increased. Look at here, the initial voltage, reverse voltage across the Zener diode is 1 volt. Then no current is flowing through the Zener, therefore it shows 0 milliampere. Up to 4 volt, up to reverse voltage 4 volt, there is no current passing through the Zener diode. So up to 4 volt, the reverse current is 0. When the voltage is increased from 4 to 4.6, Zener breakdown starts. Zener breakdown means within the crystal structure, within the Zener diode, what happens? The covalent bonds starts breaking. When covalent bonds are breaking, more number of electron hole pairs will be created. Due to the production of electron hole pair, a very little tiny current is created. That current that appears here in the form of 2 milliampere. So this milliammeter that shows 2 milliampere. Now only the current starts flowing. When it is increased from 4.6 to 4.8, still the Zener breakdown is more. Automatically more number of covalent bonds will be broken. Because of the breakage of covalent bond, more number of electron hole pairs will be created and more amount of reverse current will be produced. That is shown here as 6 milliampere. Are you clear? So that 6 milliampere will be shown by the milliammeter. Now the most significant part is here. Now if the reverse voltage is further increased from 4.8 to 5.1, what happens? The current starts increasing abruptly. Abruptly na திடீர்னு increase ஆகுதுன்னு அர்த்தம். At 5.1, the current increases from 6 to 44 milliampere. Are you clear? Now what happens? At this particular voltage, here you can't see any variation in the voltmeter. Are you clear? So here, if you dial it, if you try to increase this voltage, that voltmeter will be permanently showing 5.1. Is it clear? At 5.1, 5.1, 5.1, which one alone increases? The reverse current alone increases. This one will be a constant. The voltmeter will be showing a constant reading. But which one will be increasing? The current, reverse current will be increasing from 44 to 50, 50, 54 to 55, 55 to 60, 60 to 80, like this, the reverse current will be increasing. But though the current is increasing, which one will be a constant? This one will be the constant value. That VR will be the constant value. This constant VR value is called as VZ, that is Zener breakdown voltage. Are you clear? This particular constant value at which the current is abruptly increasing, no? This constant Zener, this constant reverse voltage given to the Zener diode is called, what is this? Zener breakdown voltage. At this particular voltage, what happens? The current is abruptly increasing. Look at the value of Zener breakdown voltage. Clear? 5.1 is the value of Zener breakdown voltage. That is constant for a particular Zener diode. Are you clear? While buying the Zener diode in the market, you can specify the value of Zener breakdown voltage, only then they will give. For this particular Zener diode, what is the value of Zener breakdown voltage? 5.1 volt. That is a Zener breakdown voltage at which current is increasing abruptly. That can be seen only by performing this experiment. Are you clear? By entering the reading in the tabular column, by drawing the graph alone, we are able to find out the Zener breakdown voltage, that is called VZ. Are you clear? There is a difference between VR and VZ. VR is the reverse voltage that is varied from 0th level to higher level. When the reverse voltage is increased at a particular voltage, the current starts increasing now. That particular constant voltage is called, what is this? Zener breakdown voltage. That is constant for a particular Zener diode. In this case, what is the value of Zener breakdown voltage for the given diode? For the given diode, that is a must one. Different Zener diode will have different values of Zener breakdown voltage. Here, for this particular diode, the VZ value is how much? 5.1 volt. Are you clear? So, different diodes with different breakdown voltages are available in the market. So, after plotting all the values, what we have to do? We have to connect all the points. Look at here, all the values are plotted. So, after plotting, you connect them and look at this. Now, the current starts increasing. After connecting this one, what we have to do? The current is abruptly increasing now. So, when current abruptly increases, now this one could be drawn by freehand drawing, and after connecting this one, here all points will lie in the straight line. Are you clear? So, the graph it would be like this. The current, it increases at a particular voltage now. This current, here the current increases at a particular voltage. Are you clear? This voltage is called, what is this? Zener breakdown voltage. That is VZ is equal to 5.1 volt. Already it is written there. Are you clear? This portion, it won't be exactly vertical with respect to the negative y-axis. Are you clear? Even in the practical, you never get the vertical line with respect to the negative y-axis. Are you clear? From this reverse bias characteristics curve, three parameters can be found out. The first one is Zener breakdown voltage VZ. The second one is minimum current to sustain breakdown, that is IZ minimum. The third one is maximum current limited by the maximum power dissipation, that is IZ max. These three parameters can be measured. What is Zener breakdown voltage VZ? Look at the graph. There you can see the letter VZ. VZ is the voltage, reverse voltage at which the reverse current increases abruptly. And then here in the case of I max, IZ max, the importance of IZ max must be known. IZ max represents the maximum reverse current. If the reverse current is increased further, what will happen? The diode will be damaged. Are you clear? The Zener diode is operated in the reverse bias condition with the voltage greater than VZ and the current less than IZ max. That is very important. Okay. So these are all the three important conclusions and three important parameters are found from reverse bias characteristics curve of the Zener diode. Okay.